the one you want. Which is better than Vulkan is going to be the best. Oh, there is going to be a war. Well, OpenGL 2 is fairly great for cross-platform. Well, I don't think there is an opinion to have on that, since Vulkan is basically the continuation of OpenGL. They just said, alright, we have too many retrocompatibility stuff with OpenGL, we should probably start from scratch, and that's what they did with Vulkan. Because both of them were done by the Kronos group. Might already know that, so that's the one. And they have many standards, among which Vulkan and OpenGL. They have OpenGL ES for embedded, so I don't know if you can use Vulkan for embedded hardware. Might have to use OpenGL ES in those situations, but I guess what I would recommend, because I've never done Vulkan, is to start with OpenGL, because it's... yeah, alright, so you already knew that. So I guess my recommendation, and what I do myself, is... well, the big difference is that Vulkan is much more adapted, suited for modern hardware, because at least... Right, no problem with that. So, OpenGL has been here for a long time, like 30 years, and you have a lot of retrocompatibility stuff that you... Yeah, that's one of the main points, because OpenGL has been around for a long time, so you have to sort of handle a lot of very old, not functions, but perhaps a very old theoretical model of what the hardware is. And that model has changed a lot a long time. And so now OpenGL doesn't really represent anymore what's happening at a hardware level. So that's one of the reasons. And also, one of the most... Hi, Kamenduru. One of the most expensive thing you do with I guess graphics API is communication between the CPU and the GPU. That, I guess, costs a lot. And they added that in Vulkan, which is called deferred rendering, which means that you accumulate the communication that you want to do with the GPU, like asking for memory or things like that, and you send everything at once. And that kind of batch processing is one of the main advantages of Vulkan. It's not deferred rendering. Well, if you're referring as to deferred rendering as, I guess, computing everything to something like that, it's different from that. Actually, because in OpenGL, what you do, yeah, they're different. So every time you want to communicate with the GPU, you send the communication and you wait for the response. And that's a problem, actually, because that takes a lot of time. And in Vulkan, you accumulate the communication and you send everything at once, and you retrieve clustered shading, I think. I don't know what clustered shading is, but yeah, so those communication aspects are the main advantage of Vulkan. Also, there is asynchronous processing in Vulkan, which means that you can send messages and still do work while waiting for the response. Also, there is multi-threading, which means that different threads can communicate with the same entry point of Vulkan. So that's a lot of very low-level stuff, but that's what makes Vulkan more efficient than OpenGL. That if you are a beginner like me, you pretty much want to use OpenGL because you have a lot more resources to learn. I guess that's usually what people do. They start with OpenGL, and as they get more comfortable with it, then they start using Vulkan instead because it's way more efficient, I guess. That's pretty much my answer to your question. I don't know if I answered it, but uh, thank you, Kamandaru, for the follow. Clustered shading. I'll look at that then. Clustered shading is an efficient and versatile rendering algorithm capable of using both forward and deferred shading system. It divides the view frustum into a 3D grid of block or clusters, quickly computes a list of lights intersecting each active volume. Uh, oh, that's really interesting. Thank you for telling me about that. I'll bookmark that and look into it for more details on future occasion, I guess. Yeah, I guess I can see what they are doing. Use deferred and forward on one of them. I wonder if it has something really to do with deferred and forward rendering, because from what I understand, basically they just render each object individually and just do some compositing afterward of the different renders. But yeah, that's really interesting. I never heard about that one before. It's probably really inefficient. Well, and I don't mean that in a bad way. And then it must be suited more for offline rendering, probably. Oh, it's used for real time too? I will have to look to do that with. to more details, I guess. Station techniques. Successful implementation. So I will be remiss not to end the post by sharing some great presentation from other more experienced devs, where they discuss their own version of clustered shading. As you can imagine, no two are alike, both in the nitty-gritty details of the implementation and in the large-scale differences found in the genres of the game they make. It speaks volumes for the flexibility of this algorithm and hints towards a future where hybrid forward effort engine are the norm for AAA products that demand highest visual fidelity. Yeah. Also, hey, I've technically implemented a clustered renderer too. You've forgotten about it after reading this world post. I don't blame you, but here's a link so that you don't have to scroll all the way to the top. It's a simplified implementation with much of the code commented so you and me in about a year, and when I inevitably forget about it. Yes, blah blah blah. So what do we have? Clustered shading in the wild by Ola Olson. Doom 2016. Emil person? I don't know who that is. Avalanche Studios. No one Unreal. Oh, on the Hunter game, I see. Ah, I guess he did a good job then. Just cause 1, 2. Solution we've been eyeing. L deferred shading, forward plus. Dev this is. Data coherence. Range coherency, yes. Freud become one. Helpful for devs. Graphics engineering is probably the most complex thing in game development. Well, it involves everyone from artists to engineers, so I can agree with that. Audio engineering can get pretty complicated too. Is there even a simple things in games to begin with? Yeah. Yeah, there are many different techniques for rendering. And you really have to get your hands dirty to actually understand the difficulty of everything. And I guess at some points that's kind of what I used to do. You know, you play a bad game, you say, oh, this game is so bad. But there are people that worked on there for weeks, if not months, if not years, just to make that whatever effects.